So let us see some basic things in this triangle inequality now in this video. So we know that in a triangle, the sum of any two sides, lengths of any two sides is larger than the length of the third side. So if we take any triangle ABC, so this is A, this is B, and this is C. So A plus B is greater than C, B plus C is less than A, and A plus C is less than greater than C is greater than B. So, and similarly from this, what we can say? We can say that C minus B is greater than A. Sorry, C minus B is less than A, and C minus, like, difference between any two sides. So A minus B is less than C, and B minus C is less than A. So difference between any two sides is less than the third side. So this can also be extended to polygons. And what is the Pythagorean inequality? It is basically the generalization of Pythagorean theorem. So the theorem states that in a right angle triangle with sides of length a less than or equal to b less than or equal to c, we have a square plus b square plus c square. But this inequality extends to obtuse and acute triangles. So for an acute triangle with side of length a less than b less than c, a square plus b square is greater than c square. And for an obtuse triangle with sides of length a less than b less than c, a square plus b square less than c square. So yeah, so that completes this thing, this Pythagorean inequality. Now let us see this isoperimetric inequality. So the isoperimetric inequality states that if in a plane, a figure in a plane has an area A and perimeter B, then 4 pi A is less than or equal to, always less than or equal to B squared. And if it is, yeah, so that's it. That's the isometric isoperimetric inequality. Now the Euler's inequality states that R is always greater than or equal to 2 times small r. So this is the in radius of the circle, no, not in radius of the triangle, and this is the circumradius of the triangle. What is in radius? It is the uh, radius of the in circle, and what is in circle? It is the, like, if we try to construct angular bisectors, so this is called as in center. So the point of intersection of angular bisectors of a triangle is in center, and the circle, the in circle will have the in center as its center, and the radius, so it is the length, perpendicular length from here to here, from the center onto the bases. So these three lengths are equal. So this is in center. And then what is circumcenter? So if you have a triangle, so the radius of this, so this is r, r, r. Since it is from the center of the triangle onto the circle, these three are radiuses and these three are equal. So that completes this Euler's inequality. Now let us see, try to solve this small example by using triangle inequality. So it is given that lengths of any two sides, lengths of sides of the triangle with positive area are log 10 to log 12 to the base 10, log 75 to the base 10, and logs n to the base 10. So you need to find the possible values of n here. So, and also given that n is a positive integer. So what we'll try to do, so log 10 12 plus log 10 n is greater than log 75. So this implies 12n is greater than 75, and this implies n is greater than 25 by 4, which is 6.25. And if we take another inequality, log 10 12 plus log 10 75 is greater than log n. So again this gives us So 12 times 75 is greater than n. From this implies n is less than 900. So from these two inequalities, and what is our other thing? So yeah, the other thing forms from these two inequalities. So now we are getting our value of n is, so 6.25 is less than n is less than 900. So which implies n is equal to from 7, 8 and so on 900. So how many values? It is 6 plus 1, it is 6 plus 2 and so on, 6 plus 893. 894 actually. So it is like we don't know that it should not equal to this, so we have to take until 899. So 899 is 6 plus 993, 893. So we have 893 number of possible values of n. So that's it for this video. Let us meet in the next video.